In this example, we're going to write some code where we're writing a dynamically allocated array that we can grow in size as needed. We're kind of making our own version of a vector. So our program is allowed to build arrays of different sizes that can expand in size as necessary. Now, of course, any individual array can't expand, but what we'll do is when an array fills up with space, what we'll do is we'll allocate a new array, copy the old values over, and continue using this newer, longer array. So in order for this to work, what we're going to do is we're first going to include kind of our IO stream so that we can see what's going on. We're going to have our int main program. And then what we're going to do here is we're going to allocate an array and print it out and make sure that we can see what's in an array before we move on with more complicated code. So let's just make an array called, I don't know, array. We won't be too creative with the name. And this is going to be of size, I don't know, 2. And then what we're going to do is we're going to pass this to a function called, I don't know, print array. And what this function is going to do is it's going to take the array and let's have it take the size of the array as well. So in order for us to keep track of the size, I'm going to make a const int named size. And this is going to be equal to 2. And then I'm going to use that size in my array to initialize it. Okay, so now let's write that print array function. So this function doesn't need to return anything. It's going to print the array, and it's going to take and now I'm just going to be explicit about the fact that it's taking a pointer to an int and a size. You know what? Because we're using this size just as a size variable, instead of using int, I'm going to use the size t type because that's what's commonly used to denote sizes for arrays. So size t type. Okay. And then what we're going to do is we're going to write code that prints out the array. Now, what I could do is I could loop through each element in the array, but you know what? I like using algorithms and iterators, so I'm going to use that instead. So I'm going to import algorithm, and I want to also include the iterator library. And then in here, I'm going to use the copy function to copy each element of my array. So I give it a pointer to the first element, which is just array itself, a pointer to 1 past the n, which is really easy, it's just array plus size, and then I give it a output iterator. So this is going to get a little bit long, so why don't I just put each of these things on their own line, and this last one is going to be a an O stream iterator, O stream iterator, and it's going to be printing out ints, and I want to pass it in cout and I don't know, a space. Okay, let's put the colon there. Let's save this code. Let's try compiling it because I've written too much code to, before checking if it actually runs. So I want to turn on all the warnings. I want to run it in std equals C++ 17 mode, and I want to compile the program called growing array. It compiles without complaining. Let's try running it. It outputs 0, 0. Okay, that looks like a good start. Okay, now right now this is really great for printing out, making an array of size 2. Let's give some initial values to the array. So like, let's say array bracket 0 is equal to 9, and array bracket 1 is equal to, I don't know, 7. Let's try compiling the code and make sure that our print array, it prints out 9 and then a 7. Okay, so I'm pretty sure our print array function is happy. Now the problem is this works for an array when we know what the size of the array needs to be. But let's make an array where we're going to be dynamically allocating it and allowing that array to change in size, or really making new arrays of different sizes as needed. So right here we have a statically allocated array, but what I want to do is I want to make a dynamically allocated array. So I'm going to say, you know, a pointer, and I'm going to call it array, and what I'm going to do here is I'm fine with it starting at that size, But now what I want here is I now have a pointer named array that's dynamically allocated. So the first time it's dynamically allocated to be size 2. Now note, all the rest of my code works perfectly fine. I can index into my array because I can use this pointer just like it was a real array and assign to it and everything. So let's make sure that by using a dynamically allocated array, everything still works exactly the same. So what I really want to be able to do is to be able to like access more than just those first two values. So like I'd love to be able to say, you know, array bracket 2, I want that to be equal to a 3. Now, of course, the array that I have here is of size 2, so it only has room for 0 and 1. But let's just see what happens if I, you know, try to access array 2. So, you know, let's say, you know, our array is really just one bigger. Let's just see what happens. So we compile and we run, and it actually works. Hey, look, we just assigned a 3 to the array. Now, the reason why that's working is because we're actually breaking the rules for C++ here. Our array is only size 2, but we're allowed to assign to values past that because what we're doing right here is we're just actually writing to memory past the end of the array. And here we're printing past the end of the array. And notice there weren't any compile warnings here. That's really dangerous. That could have crashed the program. It could have had undefined behavior. It looked like it worked here, but in reality, there's no guarantee that that would have worked. And in fact, I kind of wish that it crashed because we shouldn't be allowed to write past the end of the array. We're just writing here into arbitrary memory that some other part of a program or even a different program might be using. So this is bad. This is something dangerous to do here because we're writing past the end of the array. And notice there were no warnings to do that. Okay, so we shouldn't do that. This is bad. What should we do? Well, we can't make an array change its size, but what we can do is we can make a new array that's bigger, that is big enough for us to be able to like access the at index 2. So how do we make a bigger array? Well, that's not too hard to do. We can say int there, and we can call it, you know, array2. And what we need to do is we may need to make a new int that's of size, size, plus 1. So originally our size was 2. Now we're making a new array of size 3. And then what we can do here is we can then print out our array2 and our new size plus 1. And now when we run this, it works. Though, ooh, that's not very good. Notice that you have these huge numbers right here. How do we fix that? Oh, gosh, there's a bug right here. We then need to make sure that we're definitely assigning to our array2 here. Okay, let's fix that. So we compile, we run it, and oh, you know what's also kind of confusing? I can't tell when one array begins and another array ends. Let's put in an end line after each array. So we're going to, every time we print, we're going to output an end line after printing out the array. So let's see what that looks like now. Okay, so here is our first array, 9 and 7, and now our second array has this like huge negative number, a 1 and then a 3. Why does it have these weird things? Notice when I made my array here, I only assigned to the last index, to index 2 here. And I didn't initialize my memory here, so it's filled with just garbage. So what I might do is I might just say, hey, I want to initialize it all with zeros and then just assign a 3 to that position. And so now if I compile it, now it has zeros in all of the positions other than the one that I assigned, later on. It used to have a 0 here, but then I changed it to a 3. But what I want is I want this array to have the same values, at least, the early values from this array. I want to have a copy of this array, but this array is now just a little bit bigger. So how do I copy from this array? Well, we can use that copy algorithm again. So I want to copy. Now, what do I want to copy? I want to copy the original array. And so this is, once again, an iterator to the beginning of the array, which is just the array itself. And then we need an iterator to the one past the end of the array. Well, we can use pointers here, where we have the array itself plus the size. And where do we want it to write to? We want it to write to array2. And this will then write, and it will fill this second array with both of those values. And just to prove it, what I'm going to do is I'm going to print the array here after we filled it, and then I'm going to assign to index 2, and then I'm going to print the array again. So let's compile this. It's happy. And so here is our original array. Here's our new array after doing the copy, and here's our new array after doing the 3. Okay, that's pretty handy. However, note all the code we had to write right here to make a new array and make it bigger and things like that. Why don't we make a function that can expand the size of our array? So I'm going to make a function. It's not going to return anything, but what it's going to do is it's going to, let's say it's going to double the size of an array. So what we're going to do is we're going to give it, it's going to take the same arguments as the print array. And so it's going to take a pointer, and then it's also going to take a size t named size. We'll just use the exact same arguments. And now what is this function supposed to do? Well, it's going to take a pointer and make it twice as big. Well, of course, it can't actually make that pointer twice as big, or can't make the array twice as big, but it's going to make a new array that is twice the original size. And so what we're going to do here is I'm going to copy these 2 lines here, because this is kind of where the magic is happening. And so what we need to do is we need to make a new array that's the original size times 2, right? Because we're trying to double in size. But you know what? Let's make a variable called size t, and we'll call this, I don't know, new size, so we can save it. And it's going to be equal to the old size times 2. And so then our new array is going to be made from our new size, and we can 0 initialize it. That's not a problem. And then what we're going to do is we're going to copy into that new array. Now, great, we just made this new array, but we have a problem here. We don't return it. What I really want to do is I want to change the original array by using references. I don't want to have to return a new array. I just want to actually change the values that were passed in. Well, let's handle the size first. So notice the size originally was like a 2, and we want that size to be a 4. So what I want to say is something like size is equal to new size. Now the problem is this right here. Notice there's no references here, so this is a copy of the original size, and so we're just making a change to a copy. But if I want to change the actual argument that this was called with, I need to make this a reference. Now the same thing applies to this right here. Right here, this is a copy of a pointer. But if I want to change the actual thing that I'm going to call double size with, I need to pass in a reference to a pointer. And so here the parenthesis is needed. Is what I'm saying is I have a pointer, but I want a reference to that pointer so that I can do this. I want to say array is equal to array2. I want to change the reference that was passed in here. So let's now try calling this function. So here, let's double the size of our array2 just to see what happens. So we say double size, and we're going to pass in 2 arguments, our array2, and we're going to pass in the size of our array. So let's actually make a size t called new size, and this is equal to, let's do size plus 1. And so when we make our array, we used this variable here, and here we can just keep printing out new size. And so what I'm trying to do is I'm trying to double the size of array2. So let's just save and compile and make sure that it all works. We haven't actually printed what happens after the double size, but we'll get on that right now. Okay, so what I'm going to do is I'm going to just do a little cout here because our output is starting to get a little complicated. I'm going to say double, and let's put a nice little new line here. And then what I'm going to do is I'm going to print the array after doubling it. So let's save, let's compile, let's run. And so before we doubled it, we had 973, and then after doubling it, we have 973, and then we doubled in size, and we doubled in size with it being initialized to 0, so we got these 3 zeros. So our array now, our array is twice as big. Well, it's not actually the same array, but because we swapped it out for a bigger array and we swapped out the size for a bigger size by doing this copy. Now you might go, oh Josh, this is really awesome. You just wrote a function that can, what appears to double the size of an array if we pass it in the array and the size. That's really great. There's one big problem here. You notice how I use new right here, and I use new right here, and I use new right here? Do you notice how there are no deletes in my code? Yeah, this code has a problem. It leaks memory. Every time you write new, there better be a place where you're deleting that array. So let's look in our main function right here. You see how I have a new here, and I use this array, and then I copy from the array. And notice after this point, notice how I never use array again. Here, I'll put it. Never use array after this point. I'm only using array2 now. Do I need the old version of array? No, I don't. So at that point, I can say delete the array. And now note, I need to use the delete with the angle brackets to say I want the array version of deletes to delete that. So let's save this code and make sure that our code is still happy. And it's perfectly fine. Okay, and now the other thing to note is array2. When do we need to delete array2? When we delete array2 when it's no longer needed. And it's used all the way to the end of the program here. So at the end of my program, I'm going to delete array2. And let's save, let's compile, make sure everything's still happy. Everything is still happy. Now, what's going on in here? Notice how I'm making a new array right in here. I never delete the old array. So notice I pass in this old array, and then I make a new array, and I basically use references to allow to change the arguments, but I never delete the old array here. So how should I do that? How do I delete the old array? Well, before I change it, before I overwrite it, what I should probably do is call delete on my array so that my old array gets deleted, and then I say, okay, now make that pointer, which was pointing at now old memory, make it point at new memory. And so if I call compile, now I have a program that releases all of the memory that it ever allocates. So let's walk through here. So here I'm making a new array. I'm doing stuff with that array. I'm making a second array. Now there are two arrays. I delete my old one. So now we're back to just one array. So we're back to one array, one array, one array. And then in my double size, what happens here? I make a new array that's twice as big. So now I have two arrays again. And I do some copies from the old array to the new array. And then I delete my old array and make the pointer that we used to point at that old array now point at my new array. And so that later on, after this, I'm now having my double-sized array, and that's getting deleted. Now note, this was kind of tricky to figure out where to put the deletes in order to make my code work. That was actually kind of challenging, and that's why dynamic memory allocation is tricky. Notice, my code ran perfectly fine without having deletes anywhere, because the program was more than happy to let me just keep asking for more memory without releasing it. And to be perfectly frank, with this small of a program, the sizes of arrays we're working with, it wouldn't be a big deal if I forgot to delete them. But if I'm making arrays that are huge, and a lot of them, the fact that I forgot to delete them would be a big problem.